Now let us do a problem that is an example 3.8 which is there in the textbook. This question is based on the application of Corlash law. Now let us read out the problem, that is lambda m naught value for NaCl, HCl and for the NaAC. What is NaAC? That is a sodium acetate. Sodium acetate. Now how we write the formula for sodium acetate? That is CH3COO Na. This is a formula for sodium acetate. So that value is given and that is the values are given here respectively. So the calculate the lambda m naught for the HAC. HAC means CH3COOH. That is actually acetic acid can be represented as HAC, where AC is representing for CH3COO, that is acetate ion. So how we find it out for a weak electrolyte? Because we know that acetic acid CH3COOH is a weak electrolyte. So for a weak electrolyte, the lambda naught value cannot be find out through the plot by the extrapolation. So for that we use the application of Corlash law. We use the Corlash law here. So according to the Corlash law, what is the Corlash law states that the limiting molar conductivity of an electrolyte can be represented as the sum of the individual contribution of anion and cation of the electrolyte, as we have already learned. And for acetic acid, how we find out for the acetic acid? That is by applying the Corlash law. So we can do this in this way. For the acetic acid ion, how we write this value? That is lambda m naught for the acetic acid COOH. It can be, as we know, this can be written as CH3COO negative plus m naught H plus. So this is according to the Corlash law. But for the weak electrolyte, we cannot find it out through extrapolation. So lambda m naught value cannot be determined directly. So indirectly we can find it out through the strong electrolyte. As we know that a strong electrolyte which having the acetate ion is to be taken, that is lambda for CH3COONA, that is sodium salt of acetate ion, plus lambda m naught value for HCl, because we need H plus and for that we take HCl. Now here when you look at in this formula, here the Na and Cl, Na and Cl, here this is extra, so that we have to subtract lambda m naught for NaCl. So we will make the use of this formula, and when you split this one, what happens? Lambda m naught Na plus and lambda m naught Cl minus that NaCl, and here NaCl get cancelled. So what is remaining? That is lambda m naught for acetate ion and lambda m naught value for H plus remains. So that is why we make the use of this formula. Now we make the use of this formula in this way. So we make the formula, that is lambda m naught for HCl plus lambda m naught for sodium acetate minus lambda m naught for NaCl. Why we are doing minus here? Because in this we have to get cancelled. Na and Cl should be get cancelled, so we are taking minus NaCl. So when we make the calculation by substituting the value which is given in the problem, so we get an answer. So this is the question, example 3.8.